Hi, we are going to learn about the introduction of gas chromatography today. So we will be learning about that how the initiation of gas chromatography. So chromatography encompasses a diverse and important group of method that allows the separation, identification, and determination of closely related components of the complex mixture. Many of these separation are impossible by other means. If we look into the general classification of gas chromatography, we have two different type of gas chromatography. One is gas liquid chromatography and other is gas solid chromatography. And the stationary phase in the gas liquid chromatography is liquid absorbed on the bonded phase to the solid surface, whereas in gas solid chromatography, the stationary phase is solid. And the mechanism of action or type of equilibrium to be attended in gas chromatography of gas liquid chromatography is partition between gas and liquid, whereas in the gas solid it is adsorption. So look at here what we do into the gas chromatography. It is a complex mixture, right? If there is a complex mixture, it is being inserted into column for the separation. So there are possibility the sample could be volatile or non-volatile in nature. Depending on the nature of the sample, the method is being chosen, or either the sample has to be converted into the form which is suitable for gas chromatography. So in gas chromatography, there are two criteria for sample to be analyzed. One is thermostable and other is volatile. So if the sample is volatile, we need to go for the gas chromatography directly by dissolving into certain solvent to insert into the column, or you need to convert into the volatile form by treating it with different method is called derivatization technique, which we'll be seeing it later when we proceed down the chapter. So what happened in gas chromatography? Sample is being prepared, it is introduced into the column, then when within the column it is being separated and it reaches to detectors and it is being detected. So what happened? The two phases are chosen so that component of sample distribute themselves between the mobile and stationary phase to bring a degrees. Those components strongly retained by stationary phase move slowly with the flow of mobile phase. In contrast, the components that are weakly held by the stationary phase travel rapidly or fast. Because of this difference in the migration rate, the sample component separates into discrete bands or zones that can be analyzed quantitatively or qualitatively. Here is the sample. We have shown a pictorial explanation of the method what we have discussed. If we have a sample A and B, which is being introduced into a column, and then what happened when we poured on the mobile phase onto that, the sample by with respect to time when it moves down into the column, it separates into two different component A and B. And with respect to time, as they proceed down the column, the separation between these two components keeps on increasing, and the sample which is being retained more onto the stationary phase, which is B here, will be evaluated later. So we can see in the first picture at time 0, at T0, the sample is introduced, the T1, the sample has slightly separated from each other, and in time T2, we can see it here, the sample B and A is slightly more separated than of A at time, I mean the sample of time T1, and then at T3, the sample A is completely separated, it elutes from the column and it is being detected by the detectors. The separation of a mixture of a component A and B by column elution in chromatography. The output, the signal detector at various stages of evolution is shown here. So in this we can see, and we have got in a detector signal with T0 there was nothing, and T1 also the sample has not completely, the sample has eluted from the column, and T2 the sample has not eluted from the column, whereas T3 we can see that the sample A has eluted from the column, and whereas at T4 the sample B has eluted from the column, it's being detected from the from the detectors. So when we can show it here, this is how the separation happen. With respect to time, the separation between A and B is happening slowly. At T1, the slight separation of A and B has been shown, and at time T, the separation A and B is taking place. So this is how we learn into the gas chromatography. This is the introduction of gas chromatography, that how does the separation of gas chromatography is done and how does the chromatogram is being obtained into this. Then we will learn about the problem when the separation of the component happen. So these are the feasibility we get into the column when the separation happen. We have gotten a three picture which has to be explained, or this is a major problem what we face into the gas chromatography during the separation. So in A, the two components are being separated, but they have not separated completely. Whereas if we look into the B, the separation is better than A, whereas not good as of C. So the original chromatogram with the overlapping P is A, means this two has not been completely separated. This improvement of separation of A is being brought by in the B, which is done by increasing the band separation. And in the C, it is completely separated. This improvement is brought by decreasing in the width of the sample. So this all we will learn, or we will talk about how this is possible to get in a proper chromatogram of the gas chromatography. So basically, what does a gas chromatography do? A sample which is volatile in nature has to be separated through the column chromatography, through the chromatography, and the sample is converted into the volatile nature. So what is a chromatogram? If a detector that responds to solid concentration is placed at the end of the column and its signal is plotted as a function of time or the volume of the added mobile phase, a series of peak is obtained. Such plots are called chromatogram. Is useful for qualitative and quantitative analysis. The position of a peak on the time axis can be used to identify the component of the sample. The area as under the peaks provides the quantity measure of the amount of each components. And these are the variables that influences the column efficiency, which can be learned in a later stage to improve the efficiency of column chromatography. These are the factors which governs the separation of a component within the gas chromatography. So we'll be learning about the linear velocity of a mobile phase, which is noted by the symbol mu, and then we'll talk about the diffusion coefficient in mobile phase. We will further discuss about the diffusion coefficient in stationary phase, retention factor, diameter of packing particles, and thickness of liquid coating on the stationary phase. So overall, this is the introduction of gas chromatography, and we are going to learn in detail in the proceeding classes for the further details. Thank you.